Day 37 Notes, Financial Algebra. In this video today I'd like to walk through a few of the sample problems that you'll see in your guided notes. Now if you look at the completed notes that are available online, you'll see that I've done some write-up onto these diagrams that are showing up on the right side of my notes here. I won't talk about them in this video. That's something that we'll discuss when I come back into class on Wednesday. So I'll further explain that when I see you next. What I'd like to do is work on these sample problems that again are found in the guided notes. So perhaps you already have an idea of what floor plans are or how to read them. If you're not quite sure what floor plans are or scale drawings, I recommend watching the other videos that I've posted today in Angel before you continue work in this. The other videos are only a few minutes long each, and they do a pretty good job of explaining what scale drawings and what floor plans are. By better understanding them, I think you'll be a bit more successful in completing these practice problems. But anyway, here we go with this one. Example number 1. Jerry is using the floor plans for his new home to help purchase base molding for the place where the wall meets the floor. The plans are drawn using a scale of 1/4 inch represents 1 foot. He measures the walls on the floor plan with a ruler and finds that they total 23.5 inches. So that's important. At this point, if we know how long or what the length of the measurement is on the floor plan, we can actually turn that into a real world measurement. We know how to convert those two, or at least we'll be able to figure it out. The second half of this problem goes on to state that if the molding costs $2.10 per foot, how much will he spend on molding in total? So the first thing I'd like to do is find out the real life measurement. And what I like to do here is I look at the scale that was provided to us in the word problem, and I see that 1/4 of an inch represents 1 foot. So if 1/4 of an inch is equal to 1 foot in real life, that also means that 1 inch in the drawing is equal to 4 feet in real life. I don't know about you, but I feel just a bit more comfortable using this thought, that 1 inch of drawing is the same as 4 feet in real life, rather than worrying about these 1/4 or 1/4 inches. So if we know this value, and we know that there were 23.5 inches measured on the drawing, then what we can say from here is that 23.5 inches on the drawing times 4 feet per inch, well, that's what will tell us what our total dimensions in the real world are going to be. So if I switch over to a calculator, we can do this math. 23.5 inches times 4 feet per inch. That's about 94 feet in real life. So this equals 94 feet of molding in real life. Now I just realized that I used an abbreviation here that you may or may not be familiar with. When I use the double quotes like this next to a number, this is an indicator that I'm talking about inches. But if I use a single apostrophe next to a number, this is the measurement in feet. That's pretty common, pretty standard when dealing with empirical measurements. Now back to the question at hand. If I have 94 feet of molding that needs to be purchased and each foot costs $2.10, then we know 94 feet times $2.10 per foot will give us our total cost. So back to the calculator, 94 feet times $2.10 per foot is $197.40. $197.40. Moving on. If the length of a room is 17 feet in real life, when using a 1/4 inch equals 1 foot scale, what is the length of the room on a floor plan? Well, again, it might be helpful to recognize that 1/4 of an inch equals 1 foot is the same as saying 1 inch is equal to 4 feet. These two statements mean the same thing. Therefore, if in real life we're talking about a dimension of 17 feet, I could divide that by 4 feet to tell me how many inches are left over in the drawing. Again, because for every 4 feet in real life, we're referencing 1 inch on the drawing. So 17 feet divided by 4 tells us we're talking about 4.25 inches on our drawing. If you want to use a mixed number here, that would be fine. This is 4 1/4 inches. Moving forward again. We're going to switch now from talking about measurements of linear dimension, straight line dimensions, and now discuss what it means to have a square area dimension. In this case, Gabriella plans to carpet her living room except for the 1/4 circle shown in the corner. That area will be a wood floor where she will put her piano. The radius of the 1/4 circle is 8 feet. If carpeting costs $9.55 per square foot, what is the cost of carpeting she will use in her living room? Well, here's where understanding a scale drawing or floor plan comes into play. We can see that this is a living room with an exterior door and a window. So we've got some features here in the room. Several other windows surround the room as well. So this is a pretty nice room here with a piano sitting in the corner. And it's also quite large to have a living room that's 25 feet by 16 feet. Ends up being quite big. Now, since we have to determine the cost of carpeting, let's go ahead and start off by finding the total area of the room. Now we're going to find this total area including this corner where the piano sits. So everything that's kind of scribbled in red here, let's find that area. And that's easy to find. 25 feet times 16 feet gives me my total area. So 25 feet times 16 feet tells me that this room is 400 square feet. 400 square feet. Now in a minute we're going to recognize how we're not carpeting this entire area. We're actually carpeting everything but this semicircle in the corner. So you might be able to recognize exactly what we'll do next with this area from the corner. Let's go ahead and calculate that area. So this is the no, that's not a semicircle. This is a 1/4 circle. The 1/4 circle. Well, what you have to recognize is with this being a 1/4 of a circle, it's 1/4 of what an entire circle's area would be. So the area for this piece is simply equal to 1/4 times the regular area calculation of a circle. Now for the 1/4 circle in this drawing, that's 8 feet in radius, so the area is equal to pi times radius squared, and we're going to take 1/4 of that, again by multiplying by 1/4 on the outside. So let's see what we get for that result. Pi, we'll use 3.14159. That's pretty good. Pi times radius squared, so pi times radius, and we want to multiply that by 1/4. Multiplying by 1/4 is the same as dividing by 4. So it looks like the corner where the piano is going to sit only takes up about 50.3 square feet. So this is approximately 50.3 square feet. And so if you haven't already done so, let's start thinking about how we can calculate just the area that needs carpet. I need to adjust my sizing here because I'm running out of room. Bear with me just a second here. So that's the beauty of technology. I can just shrink this. Hopefully you've got enough room on your worksheet. But now let's talk about the carpeted area. The carpet area, well, that's equal to the total area minus the circle or the quarter circle. So we found 400 square feet minus 50.3 square feet. That's going to leave us with 349.7 square feet that needs carpet. Now, if we know that the carpeting costs just under $10, $9.55 per square foot, we can finish out the cost very easily from here. Cost is equal to the square footage, 349.7 square feet, times the cost itself per square foot, $9.55. So 349.7 times $9.55 is about $3,339.64. $3,339.64. Lots of steps in this practice problem. Hopefully they make sense. If you're falling a little bit behind or you're not quite sure of how or why I did any of the work, please make sure that you're ready to ask that question when I see you next in class. Now I'm going to skip this one in the video. I do want you to try this on your own. We basically have an area in this gray region in total. We've got the area of this unshaded region in the center. So we'd like to find out what the area of the shaded region is without considering the area of this unshaded region in the center. So see if you can come up with an expression algebraically to represent that area. The last problem I'd like to talk about in this video is good for these regular shape polygons. It can be quite difficult calculating the area of a regular polygon. In this case we have an octagon, which actually isn't too bad, but if I had a pentagon, a five-sided figure, or a hexagon, or any other unusually shaped regular polygon, those are somewhat difficult to calculate the area for. And so in the world of geometry, mathematicians have determined this formula to help us calculate the area of a regular polygon. So to calculate the area of a regular polygon, all we do is multiply the number 1/2 times the A value. A stands for what we call the apothem, and then we multiply that result by P, the perimeter or length around the polygon. So to see what the apothem looks like, let's come back to this drawing here. The apothem is the measurement from the center, the absolute center of our regular polygon, straight to a flat edge on the polygon itself. And this measurement has to be perfectly perpendicular. So if this was a stop sign and we wanted to calculate how much steel is required to make that stop sign, or in this case we're talking about a gazebo and we're trying to figure out how much wood needs to be purchased to construct the floor of this gazebo, we can now calculate that area based on the formula that was given to us just a moment ago. Area is equal to 1/2 of the apothem times the perimeter. So in this example, Delgado's landscape design is building this large gazebo for a backyard. Its shape is a regular octagon, as we see in the diagram. Now each side of the gazebo is 10 feet long. So since it's a regular polygon, every one of these sides is 10 feet. And they need to purchase wood for the floor. It costs $14 per square foot for a special type of wood. Let's find out what the cost of the gazebo's floor would be. First off, if the dimensions around the perimeter are 10 feet per section, then the apothem calculates out to be 12 feet. Or if we were to measure the center to the edge, that would be a distance of 12 feet. So as far as our area goes, that's easy to find. 1/2 times 12 times, oops, not 10. I want the total perimeter. I want the total perimeter here. So if I've got 8 sides that are 10 feet long, we're talking about a perimeter of 80 units. So if I switch back over to the calculator, 1/2, which I'll call 0.5 in this case, times the apothem of 12 times the perimeter of 80 tells me that the area of this gazebo is 480 square units. We're talking about feet here. So again, the area, 480 square feet. Now, if we need to purchase wood that costs $14 per square foot, then the price would have to be the $480 square feet, 480 square feet times $14 per square foot, and 480 times 14 is $6,720. $6,720 just for the flooring of this very special gazebo. So I think this would be a good stopping point for this particular video today. We'll pick up our discussion tomorrow and discuss the remaining questions that show up on your guided notes today. I would recommend you trying those on your own so that when we start discussing them tomorrow, the work that we go through should make just a little bit more sense. Thanks a lot.